going through that process and what we learn. Certainly when we do have failures and we're pulling a stack and we're trying to understand, well, we have discussions about, can we operate safely with the conditions of the stack and the components. We've had some good discussions and proactive ones over the last year about, addressing one of the points that Jeff made about redundancy. If we've got a certain valve or a function that's upstream of a critical reliability or closing function, is it safe to operate? We've had some good feedback loops there. And then certainly when we have found issues, either technical or QA, QC, bringing BSEE back in and feeding our learnings back to the organization, that's occurred.
One of the things that I would say...
You've probably been involved in most of those discussions.
One of the things that I would say is characteristic of the maintenance activities on rigs from our perspective is that you never have too much. I'm not aware of very many discussions where people are happy to reduce the amount of BOP maintenance that is done on rigs. We've done a variety of maintenance studies. I would say almost all of those studies have recommended less maintenance for a variety of reasons. Reliability engineering, again, looks at the so-called bathtub curve where we have high failures at the very initial parts. Now, obviously, with better training and vetting of parts and that sort of thing, we can do better. But even with good data, even with good information, there's a great reluctance of people to reduce maintenance as a general thing. And if you can look at the performance of rigs on an individual basis, I've heard the term, the circus game, whack-a-mole. When you get good performance in one area and a bad one in another one, you move some folks around, and the next thing you know, we've got a different poorly performing rig. So we've got a long way to go there, but I think we can do that.
Thank you. Any questions from the floor? I think there's one over there.
Good morning.
Good morning.
Quick question. This is a manufacturing question, I guess. I was wondering, to duplicate the, let's say, 2,200 PSI of external pressure at the manufacturer's facility?
Well, we haven't drilled at that depth quite yet.
No, 5,000 feet of water.
That's about 2,500 or so round numbers.
Oh, did I say 25,000?
Yeah,
2,500, sorry.
Yeah, okay.
That's what I meant, sorry.
That is a problem with hyperbaric testing. Most of the chambers, I think there's one, correct me if I'm wrong, I think there's one in the States that can do hyperbaric testing with significant pieces of equipment. So that's a challenge.
But the whole unit basically has to operate as a electro-hydraulic, whatever it is, 60 feet high. So I'm assuming that there is no hyperbaric chamber that's big enough to put the whole unit into that type of external pressure.
Not today.
That's correct. One question over there.
Hi, I'm Kent Satterley with Shell, and I'd like to refer to something that Mo said a little bit earlier. He said, tell us what you want and let us figure out how to do it. And I think, Mo, if I can just expand on what I think you were saying, I think what you were saying was don't stifle innovation. Tell us what you'd like us to achieve, and then let us use our capabilities and our technology to solve that problem. Part of the purpose of this workshop is obviously to collect information on BOP performance and capability, but I think it's also for BSEE to try to understand what this regulation is supposed to look like and what it's supposed to do. The history of rulemaking, particularly since Mondo, has been rather on the prescriptive side. The problem with prescriptive regulation tends to innovation. To the panel is how might the regulation look like that and technological advancements in BOPs and well control.
It was well said. I don't know if you do, but again, define the objective and turn us loose. Here we are. We've gone in since my first quote deepwater rig was in 1970. The Ocean Queen, and 600 feet was considered the deepest, and we've progressed now to 12,000 feet over that little bit of time. And we've taken early multiplex systems that we put on. I was building our first DP drill ship in '77, and we put a first generation multiplex system, and we made it work. I guess the key here is there are many ways to skin a cat. I was very fortunate to be in the United Kingdom. I was our area manager in the United Kingdom when the safety case regime started in, and we started seeing the differences between prescription and goal setting performance issues. So we can achieve what everybody wants. Don't box us in too much so that we can ensure that we can get that innovation and we can move ahead where we want to go. Don?
Just to add to that, good question, Kent. I think going back to Tom Hunter mentioned this morning to, the government's role is to deal with the what rather than the how. So I think that's what Mo was also reinforcing. And I think, Director Watson has talked about in many public spaces about ramping up the capabilities of the BSEE organization and technical capabilities, and that's work in progress. So I think there's an opportunity to work together on the defining the what, but there's got to be a strong industry influence into that currently, just from a capability standpoint. And I think being able to the only way, if we go down a prescription route, and I think that's the point you were making, Kent, is it's very hard to change from that. Updating those is slow and cumbersome and will not keep up with technology development. So we have to design a system that specifies what we really need, what the performance criteria is be based on, and then let us, like Mo says, let us get after it and come up with the solutions.
I think in this industry we have one of the greatest technical challenges of our time in a modern basis. Everybody's talked, if you go to different industry conferences, one of the common themes is people and how we have not very many of them. All these things that we're talking about doing are going to require more people, more technical staff, more trained advanced technology and focus. And I think the issue that we have in order to do that is to understand priorities. We all want to do everything right now, but we simply don't have the staff to do that. So it's particularly difficult then if we go to a performance regime, which is more difficult to understand. Do the right thing. How do I audit against do the right thing?
Any more questions? I think there is one over there.
I would, while you're getting the mic, I would argue though, Jeff, that there's a level of definition in the what that it's not a free-for-all. So
No.
so it's clearly this is what it needs to do, how, and then I think we could work in that space.
No, I agree. I'm in favor of a performance-based standard because it provides that flexibility and encourages innovation. It's just more difficult to deal with by all parties.
Okay, thank you.
Nick Lorette with Noble Energy. I think Jeff had a great point when he talked about testing, the amount of testing we're doing and the impacts that testing is having on the system as a whole. We're doing a 15,000 PSI function test, or actually pressure test on all functionality on the test on the surface. Then we're splashing the stack. We're testing every single functionality again. Every 14 days we're doing a pressure test on every functionality of the stack. And then every 7 days we're testing the functions again. So I guess my question is do we truly understand the impacts that testing's having? And before we pass any more regulation, are we going to put any science behind that testing and how it's impacting reliability of the stacks? Because I can tell you from my experience post-Macondo, we're seeing more test failures, we're seeing more stacked pulls, and so what I would deduct from that is that reliability is decreasing. And so going back to what we were saying earlier, yeah, we want to see more functionality out of the stack, but I don't think we've gotten the current stacks right because we're not at 100% reliability. So how can we move forward until we get what we have right?
Thank you. I think that's just a statement you made. Okay.
I don't know. Great question. Yeah. I don't know if any. It's a good. I really can't answer that. I don't know of any plans for a rigorous testing program. It may be something that needs to be mooted a little bit more about, you know, the benefits, how it would be done, what we could get out of that, and how long it would take. Think about it, Jeff.
One of the key issues, I think, I absolutely agree that we need to do some more testing, but one of the panelists earlier talked about the fact that let's keep in mind of how many pieces of equipment of this type are in service today. You go and to buy an electronic component, you can buy it from a number of places. They test them to failure. There's 68 zillion whatever. But the fact of the matter is we're talking about hundreds of pieces of equipment here, a very small universe that makes the statistical analysis very difficult. Not saying that we can't or shouldn't do that. Just we have to keep in mind the reality of the number of the universe of installed equipment that we have.
Okay, I think we got time for one more question.
Rocketdyne. This has to do with requirements. We heard mention of requirements. It ripples through all parts of the life cycle, availability, reliability, and then down to the granular level of every part and system. What suggestions would you have to assure that requirements are traceable into the product, its performance, are verified and validated for the intended function, utility, or some quantifiable value, and are also verified and validated for the worst case scenarios where we might, if you will, try to break the software and see how robust it is?
Okay.
Yeah, we need a manufacturer. Yeah. Got any valve manufacturers around?
I think this is more to the manufacturer. They can answer because, in my opinion, drillers are just doing the maintenance for the OEM manuals.
I'll make a stab at that, if you will. One of the things that I think that we could take great steps in improving is the transparency, if you will, in the transfer of information. One of the things that has been particularly problematic of not just BOP but other systems as well is what exactly is equipment designed to do from a controls and software perspective. I think generally speaking, I would characterize what the owner of the equipment receives from the manufacturer, something like the light on your car that says check engine. That's just not acceptable. We can't afford to have a check engine light and then have to figure out what the software is doing. Recently had an issue where the particular manufacturer had a solution to a particular failure mode of automatically evoking an emergency disconnect sequence. I've not met anybody, once they learned of that thought that was a good response to that particular failure mode. What other kinds of things are buried in that software that we don't know about? So I certainly encourage the transparency of information as it relates to the transfer of electrons and making decisions one way and another.
Yeah, thanks. I mean, the thinking is about how you can verify the requirements are addressed. Some of them come down certification, maintenance, and so forth. But it's hard to see if that's done consistently and if this is something the drillers will push for or the OEMs will bring or it'll be pushed down ultimately by the oil customers. Thank you.
Okay, I think we are running out of time, so we'll conclude our panel over here. And thanks for everybody here, and thanks for participant.